So this is asking for the resistance of an electric frying pan that draws 12 amps of current when connected to a 110 volt circuit. So this is our current. So that'll be I in our problem. And then we have 110 volts. That'll be V. And then we want to know R. So like I said, I like to write what I know over here. And which is a lot faster on paper. And I know some of you are turning in your work, like trying to type all your work to like these math problems. If you want to print it out and write it and then like take a picture of it and share the picture, you're more than welcome to do that because I know it probably takes like a ton of time to try and write all those formulas and stuff on the computer. Like I've been really impressed that everyone's taking the time to do that because wow, that takes a lot of time. Okay, so our formula is R equals V over I. This is another one of those triangle formulas, but we don't have to put it in the triangle because we're at R and that's all. That's what we needed anyway. So we're just going to do 110 over 12 and put this in my calculator. I'm going to get 9.16 repeating. So I'm just going to write 9.16 or 9.17 actually that way. And now your unit is ohms. Like I said, that's kind of hard to write on the computer. So by all means, if you guys want to write like type 9.07 and then write ohm, like OHM, you're more than welcome to do so. That's not going to hurt my feelings one bit. Okay, so then we have another problem, and since this one didn't take up that much space, I'm going to just do it on the same one. Okay, so this one says a 25, and then on your worksheets and stuff, they Anna, like I was saying, I told them earlier, I don't actually make any of the worksheets or anything in this course. They just kind of drop me in the course and everything's already here. So in a lot of the worksheets and stuff, they just say like, they have like a box here or like the actual ohm symbol. It looks like they tried to use it and it doesn't show through for some reason. So whenever you see something like blank like this, especially since this worksheet's called like Ohm's Law, that's that was supposed to be this little symbol and it didn't transfer for whatever reason. So this one is asking for the current, which is I, and then this is going to be your resistance. This is going to be your volt. So your R is 25 ohms and your V is 12 and then your current is I. And the units for that is amps. So I'm going to put that there so I don't forget. So I'm going to do R equals V over I again. And this one, since we are looking for I, I'm going to go ahead and put it in the triangle. I've got R, V, I. Okay, and I'm looking for I. So I'm going to cover that up. And so I'm going to do I equals V over R. So I'm going to have my 12 over my 25. And you're going to get a small number, kind of close to a half, I would guess, since 12 is almost half of 25. Yeah, 0.48. Amps. Okay. And then they have another question that makes you solve for volts. And basically what they're doing is they're having you try each kind. So you see how it says like 12 blank resistor? That should be ohms. Like I said, it wasn't showing up. It's just that symbol doesn't show up all the time because it's weird. Oh, I just said A. This is going to be your current, so this is your I. And the units are A. And then what I know, or what I'm looking for, is volts. What I want, or what I have, sorry, is 0.75. My R. So then I'm going to have V, or sorry, I've got this, I've done these so many times, V equals I over R, I've got that part memorized, but that's not technically the main formula, so we'll solve for it. So we have R equals V over I, we need V. So V's on the top, I, R. We are looking for V. So we're going to do V equals. And I'm just putting I in front of R because out of habit. You can put R in front of I if you want, like it's in the triangle. Like I said, it's just habit for me because I've done these so many times. So I'm going to do 0.75 times 12. And I want to say I'm going to get like 9. It's 3/4 of 12 is 75. Yeah. So we get 9 volts. Okay, so now we've done one where we've solved for R, we've solved for I, and we've solved for V. Now, then they give you these problem sets. I'm gonna take these out, and I'm gonna this one says your pet parakeet flies out an open window and perches on a high voltage wire. Why isn't the bird electrocuted? So this is kind of what we were talking about this week, right? You've got a wire, right? You have like all these wires that kind of hang like that from up high, and then you have your little bird. I'm not a great bird drawer. There's my bird. And so they ask, why isn't he electrocuted? Well, you've got these poles, and the current is flowing through, right? But in order to have a circuit, you've got to have a closed circuit. So you've got to have a loop. It's got to be able to, go like this. So if the bird had like a really long tail, then, the current would go through here and through here, and your bird would get electrocuted. But since, most birds don't have tails that long, he's not getting electrocuted because he's only on one wire. So his like all parts of his body is at the same high voltage. If he were to be touch 2 wires, then he would get electrocuted. So then the question asks, if you fell from a tree onto the same wire, would you get electrocuted? So then it asks this. Well, if you could find a way, if you fell and you could make sure that you only touched this wire, the same wire the bird was on, then you wouldn't get electrocuted either because, you'd be on the one wire. But if you're on this wire and then like your shoelace touches the second one, or, you slip and you grab the other one or whatever, then you'd be electrocuted and you would probably die. And so then they ask, should you touch the bird to rescue him? Well, if you touch the bird to rescue him, right? So say there's a ladder over here and you're climbing up this ladder, and you're going up the ladder, then now your ladder's touching the ground, right? Let me see if I can make an arrow. Yeah. So your ladder's touching, whoa, I didn't mean to do that. So your ladder's touching the ground. Ooh. And then, okay, I don't know what I did there. I'm just not even gonna attempt that. Your ladder's gonna be touching the ground, and then you're on the ladder, and then you touch the bird. So now you've provided a path to the ground, and so you're grounding the bird, right? And so now there's a place for that charge to go, and so you and your bird will probably die. So yeah, just leave him there. Don't move your bird. Just let him stay.